Hello, in this video I'm going to bring together Netgen and Open CASCADE technology in order to build mesh for an Open CASCADE's shape. Last time I built Netgen and currently I have all ingredients to harness meshing problem. Today I have prepared a libpack for third-party products including Netgen, here it is, Open CASCADE technology, here it is, and the lib library. Also I have a model to mesh. It looks like it's well-known ANC 101 model, and also we have empty folder for code itself. Let's create an empty project in Visual Studio. New project. Let it be wrap to mesh. Let's switch to existing for mode and to release. And also we need to add a new file, add new item, main.cpp, and let's create empty main function. Let's make our font a bit bigger. Here we are. Our next step is to define inputs and outputs. In our case, inputs and outputs will be quite simple. From one input shape in wrap format and argv from 2 output mesh in STL format. By the way, BREP, it's internal format of Open CASCADE technology. One can use here step or IGES file also. Our next step is to define the building blocks of this small command line application. The first block is reading. We need to read Open CASCADE technology's shape. So we have 3 big blocks: read, mesh, that would be like, I don't know, read, mesh, and save. We're not going to use any smart mechanism for third parties handling. We will integrate everything to this instance of Visual Studio just for simplicity. And the first step here, we need to add our includes. Here we are. Go into C++ node, go to general, additional include directories, edit, and we need to add all 3 libraries we have here: Netgen, Open CASCADE technology, and the lib library. By the way, we will need to update the list of include directories for Netgen, and we will see it a bit later. We added to all configurations, so we can apply it. Okay. And we need to include some include from Open CASCADE technology. Let's split our includes into groups. Includes from Open CASCADE technology, and this one is used to read the file into entity called topo.ds shape. Topo.ds shape as, and let's see the interface for read method. We need to read into variable s. We want to read from argv from 1, and we need special object called BRAP builder. We don't need to create it. We can just use default constructor, and that's it. We see that it's incomplete type, so we need to BRAP builder. Let's sort our includes alphabetically. Okay, here we are. And the next step here is to integrate Netgen. Includes from Netgen. There are a lot of warnings in Visual Studio, so let's suppress them. And for that purpose, we can add pragma warning push 0. Pragma warning up, and within this block we can add Netgen includes. Netgen uses special macro OCC geometry so we need to define it. Geometry. No. This macro enables Open CASCADE functions, and we need to include two header files, occgeom.hpp, and we see that this include is not available, so we need to update our include paths. And we need to include OCC, meshing, and OCC, meshing, and include. And also we need to include main file of Netgen. It should be included this way in glib.h. Great. For our mesh, we should establish some meshing parameters. For that purpose, let's do it automatically. So we need to create instance of bounding box for shape. It's just axis aligned bounding box. We need to calculate bounding box using brep bnd lib add, and it accepts shape, axis align bounding box to store the result, and we are not going to use triangulation, so let's use original geometry. For a maximal mesh element, mesh size, let's use some fraction of bounding box diagonal. Const double square, not square, but diag. It stands for diagonal. And here we calculate std s square t from axis align bounding box square extent. And we need to pass the fraction of this value into the meshing process. For that purpose, Netgen has a special instance of parameters during meshing. It is stored statically. So Netgen meshing parameters reference mp Netgen m_param. And we need to tune some parameters. So minimal element size without constraints, maximal element size, let be 1% of diagonal, mp dot use local h set to true. This parameter is extremely important for meshing because it allows Netgen automatically adjust these sizes according with sizes of underlying geometry stored in top-of-the-S shape. So without setting this parameter to true, some shapes cannot be meshed. And let's set grading to 1.0. Netgen stuff should be initialized and wrapped by two methods, ngleap, nginit. And here we need to pass top of the shape to a form which is known to Netgen. Netgen supports Open Cascade shapes natively, so we can write it like Netgen OCC geometry, it's OCC gel, OCC gel dot shape equals to S, OCC gel dot changed equals to 1, and we need to call two methods to initialize other fields available in this class. OCC gel dot build fmap, it builds a map of faces, and OCC gel dot calc bounding box. After we prepared all necessary data, we need to create a structure storing the result. So resulting mesh in Netgen form. It is Netgen / mesh. And we need to build mesh. Netgen, like almost all meshes I know, it uses increasing order of meshing construction. First of all, we need to discretize edges to build 1D mesh. After that, we need to discretize faces to build surface mesh, and optionally we can build volumetric mesh. So it means that we build three-dimensional mesh. For today, let's stop on 2D mesh. So mesh building block, it has three methods: Netgen, OCC, set local mesh size, OCC gel, and mesh as a result. So it just adjusts local sizes for more robust meshing. After that, we need to discretize our edges. Netgen, OCC find edges, OCC gel, mesh, discretize edges. And the last method we need to call here is Netgen OCC mesh surface, OCC geo mesh, and we can stop on Netgen mesh const mesh surface. Alternatively, we can optimize resulting two-dimensional mesh. Discretize faces. After that, we need to convert this object into a form suitable for STL exporting. As far as I know, there is no way to store Netgen mesh into STL format, so we will convert this object into Open CASCADE mesh and we will save it to STL. So we need to get number of nodes, int mesh dot get and get number points. Yep. Const int number of triangles. So once again, int mesh dot get and SE. Here we assume that mesh contains only triangles, no quads are expected. We create Open Cascade mesh, poly underscore triangulation, result, new poly triangulation, be nodes, be triangles without UV nodes. And we need just to copy data. By the way, Netgen uses one-based indexing. So for I int I equals to 1, I lower or equal and be nodes, const Netgen mesh point mesh dot point Netgen index, not index but point index. And result, change node from I, set cohort, point from 0, point from 1, and point from 2. And we also need to copy triangles. Const Netgen element 2D lem where is the reference mesh dot surface element Netgen element index and result, change triangle from I, set lm from 0, 1, and from 2. Our Netgen stuff is over, so we can exit from Netgen. And we can write resulting poly triangulation into the file using rv.stl. I don't have an access for it, so I need to include it. STL, yep. And I can write it like rv.stl, write let it be binary, result, OSD path, rv from 2. And now we need to add libraries and DLLs into Visual Studio in order to build and launch. So here you see that we have a lot of unresolved external symbols. Let's start with integrating libraries. So go to the linker, general, additional library directories. Deps, Netgen, libraries. One more library here. Deps, Open CASCADE. The same for libraries. So you can see that we tune everything for release mode. And we need directly pass the names of these libraries to Visual Studio. To do it, we can just copy the names of corresponding libraries like this. For Open CASCADE. All these libraries. Of course, we don't use all of them, but I'm too lazy to distinguish between used and unused libraries. glib.lib and core.lib and the lib.lib. Yep. After that, we expect that everything will compile. We also need to tune our environment variables in order to be able to launch it, because currently you see that our libraries are missing, and for that purpose we can open Visual Studio Project properties, and we have here environment type, and we can type here path equals to, and we can just copy these three paths to our binaries. This one, path to Open CASCADE binaries, and path to the lib libraries. And also add original state of variable. Now we see that the software launches, and we need to pass input command line arguments to launch it. demo2 anc101.grep, anc101.stl. Let's open the resulting file using MeshLab, for example. Open anc101. Here it is. That's it. Thanks for watching.